Okay, in this example, we're going to take some inequalities written in modulus form and write them as standard inequalities. Once we've done that, we're also going to think about a different way of interpreting the modulus function that can sometimes be helpful. So in part A, we have mod of x minus 4 is less than or equal to 9. For values of x bigger than 4, inside the modulus bracket will be positive, and that means the modulus function won't change it. So we can say that x minus 4 must be less than or equal to 9. If the value of x is less than 4, then inside here would be negative, and then when we mod it, it would still be less than 9. So it's not possible to get a value inside the modulus bracket that is less than minus 9, because then when we mod it, it will be bigger than 9. And that tells us that x minus 4 must also be bigger than or equal to minus 9. From here, if we add 4 to each part, we get x is less than 13 but bigger than minus 5. That's the answer to the problem, but I'd like to go a bit further with this example so that we can see something else you might not previously have thought of. First of all, I'm going to express my solution on a number line. So x can take any value between minus 5 and 13. And right in the middle would be 4. And what I'd like to do is take a look at the distance between 4 and the endpoints of the interval either side. To get from 4 to 13 is a distance of 9. And to get from 4 to minus 5 is also a distance of 9. And can you see the links between these values here and the values in the original question? So one way of conceptualizing this modulus inequality here is as follows. So what I've written here is the distance from 4 is less than or equal to 9. And that statement there is another way of interpreting this modulus inequality up here. If we have x minus something, whatever that value is, we're saying the distance from that value is less than or equal to whatever we have on the right hand side. Let's have a think about part B. This time we have mod of x plus 1 is bigger than 6, and we want to write it as two separate inequalities. If x is bigger than minus 1, the modulus will be positive, and so it must be the case that x plus 1 is bigger than 6. If we had a negative value inside the brackets, then when we take the mod, in order for that to be bigger than 6, it must be the case that before we took the mod, the number has to be less than minus 6. So we can write down a second inequality that says that x plus 1 is less than minus 6. And then we can simply rearrange these. We subtract 1 from both sides here. And the same here to get our answers. Again, let's have a look at this on a number line. We have any value bigger than 5 or any value less than minus 7. Once again, let's consider what number comes in the middle. This time, the middle number is minus 1. We could maybe have predicted that before, because here, x plus 1, you could write that as x minus minus 1, and then it will be written similar to how we had in part A up here. So the central value is minus 1. And if we look either side, we have a distance of 6 in both directions. And so this modulus inequality can be interpreted as follows. The distance from minus 1 is greater than 6. Right, that's quite a lot to take in one example. So take your time when you apply it to this next problem. Try each step for yourself first, but remember you can always use your answer to the example we've just done as a template to help you through. With this question, once you've got the inequality written in the correct form, I'd like you to try and write a sentence in the same form that I did in order to describe the inequality. Okay, pause the video and then come back and check your solution against mine. Welcome back. Here's my solution then. Okay, if you got it correct, feel free to move on to the next part of the lesson. Otherwise, I'll go through my solution now. So this time then, we've got mod of x plus 3 is less than 4. That can be written as an inequality where we have minus 4 is less than x plus 3, which is less than 4. Subtracting 3 from everything gives us minus 7 is less than x is less than 1. So there's the answer to the question. Let's draw it on a number line. In the middle of our number line is negative 3. And so here is a sentence to describe the inequality. The distance from negative 3 is less than 4. In part B, we have mod of x minus 5 is bigger than or equal to 1. This tells us that either x minus 5 must be bigger than or equal to 1, or x minus 5 must be less than or equal to negative 1. Adding 5 to both sides gives us x is bigger than or equal to 6, or x is less than or equal to 4. If we draw that on a number line, we get this. The midpoint of the interval is at 5. And so the sentence we can use to describe this inequality is as follows. The distance from 5 is greater than or equal to 1.